boys and girls. There's no need to write this down right now. I'm just trying to show you why we're going to do what we're going to do, and I think you'll be better off by seeing this. Do you remember what the antiderivative of 1 over x is? Do you know what the antiderivative of 2 over x minus 4 is? So, here's the point. This is really easy to find. It's really easy to look at this one and identify exactly what the antiderivative is. It doesn't require really any substitution. It's pretty straightforward. What if you were trying to find the antiderivative of 1 over x squared minus 1? You know, some people look at a problem like that and they're like, well, maybe it's natural log of something. It is, but let me just show you the difficulty. Don't write this down, okay? Well, that's the road we'll go down. But let's suppose you had that, okay? And we're not doing integrals today. We're getting ready to where we could do integrals, okay? There's a part of pre-calculus that gets left out of curriculum now that is really important, you guys, moving forward. Isabel's seen it. I saw it. Other people have seen it. It's being put by the wayside. We just don't push quite as far as we used to. And then all of a sudden you get to Calc 2, and people are like, well, haven't you ever seen partial fractions before? And you say, no. So look at this. You look at this problem. You say, well, let u equal x squared minus 1. So then you would have a 1 over u, right? And what's the antiderivative of 1 over u? Natural log. But here's the problem. As soon as you find u, you have to find du. If u is x squared minus 1, what's du? 2x. Do you have a 2x? No. So therefore, this doesn't work. It doesn't work. So forget about doing anything at all with integrals. Let's just work on what they call decomposition of fractions or partial fractions. Let me show you what happens. We want to rewrite this, okay? I'm going to rewrite it as follows. Would you guys agree that this is the same thing as 1 over x minus 1 times x plus 1? Everybody okay so far? Okay, so now I'm going to split it up a little bit. Would you agree that that came from something, namely it came from this fraction? Would you agree that maybe when you took the two original fractions and added them together, that's what you had? Doesn't seem reasonable, right? Okay. And what happened is you had some number on top of here, okay? It's some number A, it's some number B. What did you do to this side in order to add these two together? You multiply the top and bottom by x plus 1. You multiply top and bottom here by. So that fraction became a times x plus 1 plus b times x minus 1 all over x minus 1 times x plus 1. You agree? Okay. The bottom. Does the bottom equal x squared minus 1? Yes. The top. right now it's not necessarily equal to 1. Our goal is to figure out what would A and B have been. What would they have been in order to get this to be 1 at the top? Let me show you how we can do that. What values for A and B? Should A be 2 and B be 5? Should A be 6 and B negative 4? What should they be? And here's how we do it. A times X, AX. A times 1, A. B times X, B times negative 1. And that in the end should equal now something interesting here as you look at it. Here we have an X term. A times X plus B times X. Do you have any X terms in your resulting fraction? So therefore, A plus B should have to be equal to what? 0. If you have no X terms, if they go away, then if you take AX and add it to BX, you have to get 0. Does that make sense? Do we have a constant term up top? 1. So if you take A minus B, because those are my constant terms, you should get 1. So this you could also write this as AX plus BX equals 0. But I wrote it like this because it's a system of how many equations? 2. What process, graphing, substitution, or elimination, can we use to solve this? Let's just use elimination. What's A plus A? 2A. What's B plus negative B? 0. And what's 0 plus 1? So what is your A value? What's your B value? Get your original fraction, A over X minus 1. So this would be 1/2 over X minus 1. Plus negative 1/2 over X plus 1. Can't have a complex fraction. So let's just write it in the final step. Multiply by the reciprocal, and you get 1 over 2 times X minus 1 plus, oh actually, I'm sorry, minus 1 over 2 times what? X plus 1. That fraction is decomposed from that fraction. If you would subtract these two fractions, you would end up with exactly that. The deal is you can't take the antiderivative of this. You can take the antiderivatives of each of those. See how involved that is? Then we would take the antiderivative. We're not taking the antiderivative today. There's 4 steps. There's four levels of partial fractions. I just want you guys to see the first 1 or 2. That's it. Okay? You can learn the others when you get to Calc 2. But if you see this, it will be helpful. Let's do another one together, and then you can try 1 or 2 on your own. Okay? We're going to go at a very slow pace. Let's do number 3 together. Let's do 3. Okay. This fraction, okay, can be rewritten as 3 over what 2 things multiplied together? So in other words, there's, you know, some piece on top, a, over x plus b over x minus 3, that will give you that result. Well, we'll take care of the 3 in a little bit. Okay. So if you were to add, and you guys, I'll admit this is only the second time I've ever taught this, and so your questions are going to be very much valued as we figure out kind of how this works and the best way to talk through it. So we got a over x plus b over x minus 3. What would you do here in order to combine these fractions? Multiply by x minus 3. So you have a times x minus 3, okay, plus what would you do to this side? B times x, and that would all be over x times x minus 3. So you can see here that is x times x minus 3 equal to the denominator? It is. The numerator, we want a times x minus 3 plus b times x to come out to be 3. That's what we want. Let's make it 3. So what we do is we set up ax minus 3a plus bx. That hence has to end up being equal to, and I'll write it like this. How many x's do we have? No, we have 0 x's. How many constants do we have? We have 3. We have 0 for our x's up top here, and we have 3 for our constant, right? So would you agree that ax plus bx has to end up to be 0x? Or a plus b has to be 0? So those are my x terms. Let's look at our constant terms. I have negative 3a. Do I have any b? Oh, so I have negative 3a equals 3. Can we just solve that bottom one? Yeah. And we divide both sides by negative 3, and we get a is negative 1. If a is negative 1, b is positive 1. Because they have to add to 0. So I'm doing my systems of equations here. Now I can put this negative 1 right there. Negative 1 over x plus 1 over x minus 3. Or if you want to write it 1 over x minus 3 minus 1 over x. The deal is, can you take the antiderivative of those? Yeah, pretty easily. Can you take the antiderivative of that? Very, very difficult. So, you can see the value when you're doing integration. Again, can you take the derivative of that? Yeah, taking derivatives is a piece of cake, upside down. But antiderivatives, very difficult sometimes. And so we find these crazy techniques. I was in a graduate course a year ago. I was in this one. And the professor came up with a problem on the board. We weren't doing integrals, we were doing something else. He said, and this is where we just start scratching our heads and don't know what to do. And I raised my hand and said, partial fractions. And he looked at me like I was born in another planet. He said, you're right. And I said, lucky guess. I said, so they do come up in more places than just integration. So, and there's different levels of partial fractions. So go ahead and let's right now try 2 and 4 on your own, and let's just play around with it and see if we can get it to work. Okay, try to follow the same process.